Imagine staring up at a black hole, a cosmic beast so dense that not even light escapes. Stephen Hawking takes us there, to the edge of the universe's deepest secrets, asking, what happened at the very beginning of time itself? And more mysteriously, does time really flow just one way? These questions pull you in like a rabbit hole, but the answers Hawking teases out are even stranger than you expect. Hawking kicks off with the Big Bang, the explosive birth of everything. But what set it all in motion? We're not just talking ancient history. This moment reshapes how you think about existence. In Cambridge, Hawking described how 13.8 billion years ago the universe burst forth from an infinitely dense point, a singularity. Imagine the entire cosmos squeezed smaller than a proton, then exploding faster than anything you can imagine. But what caused this bang? That question is a cliffhanger Hawking keeps returning to. Was it random, or scripted by laws beyond us? Picture the universe like a giant party balloon. As it inflates, every dot, the galaxies, moves away from each other. But instead of dots moving on the surface, space itself stretches. This means there's no center you can pinpoint. Every observer sees themselves as the balloon's heart, expanding away from everything else. Here's a mind bender. Unlike a regular balloon, our universe has no edges or boundaries. Space wraps around itself in a way that makes outside meaningless. This flips your common sense upside down, because if there is no edge, does outside even exist? Hawking's ability to reshape reality makes you question what place really means. We take for granted time's arrow, always pointing forward. But Hawking unpacks how time's direction is not just natural, it's deeply linked to the universe's shape and fate. Spoiler, time might bend or even stop. Hawking illustrates time's arrow with a thought experiment about a broken teacup. When the cup falls and shatters, time flows forward, shards don't reassemble. This simple act keeps time irreversible. But imagine if, under exotic conditions, the arrow could reverse. That terrifying possibility challenges everything we know. Entropy, a measure of disorder, ticks upward relentlessly, like a clock counting down to cosmic heat death. Hawking compares it to an egg scrambling itself. Easy to scramble, impossible to unscramble. This imbalance underpins time's forward march, rooting thermodynamics at the heart of temporal experience. Black holes with gravity so intense that even light can't escape warp time itself. Hawking famously showed that near a black hole's event horizon, time slows dramatically. Inside, what happens to time? Here, Hawking's revolutionary idea of black hole radiation hints time might leak away, reshaping the universe's ultimate destiny. Black holes aren't just cosmic vacuum cleaners, they're gateways to physics beyond our wildest imagination. Hawking takes us inside these mysterious wells of gravity, where laws break down and mysteries pile up. It starts when a massive star, much bigger than our sun, runs out of fuel and collapses under its own weight. Hawking describes how this collapse squashes matter into an infinitely dense point, a singularity where gravity crushes space and time themselves. Imagine matter squeezed beyond comprehension, but what happens next remains one of physics' biggest cliffhangers. The event horizon acts like a one-way door surrounding the singularity. Cross it, and you're trapped forever. Hawking likened it to an invisible prison wall, beyond which information was thought to vanish. This boundary challenges our deepest ideas about reality and whether information can ever truly disappear. Then came Hawking's stunning insight. Black holes aren't totally black. Instead, they emit a faint glow, now termed Hawking radiation. This radiation implies black holes slowly evaporate over eons, losing mass and energy. So these cosmic giants have lifespans, raising jaw-dropping questions about what happens when they vanish. You might picture the universe like a map with edges. But Hawking flips that idea upside down, revealing a cosmos without borders, raising profound questions about where space ends and what lies beyond. Drawing on Einstein and his own work, Hawking explains how space can curve back on itself, like the surface of the Earth, but in higher dimensions. If you travel far enough in one direction, you could end up where you started. Unlike a flat map, this curved space suggests no edge, a universe that's finite but boundless. Think of the universe like the surface of a sphere. It has an area but no edge. Hawking invites you to imagine 3D space wrapping in the fourth dimension, a tough mental leap. It means the universe's size could be limited, yet you wouldn't encounter a wall or fall off. Hawking's revolutionary, no-boundary proposal imagines the universe as a smooth, closed surface in time and space, without beginning or end as we perceive it. Instead of a start or finish line, time itself is like a circle. This elegant idea hints that asking what came before the Big Bang might be a meaningless question. Will the universe expand forever or collapse? Hawking explores how everything might end, if at all, and what it means for the tiniest specks of matter and the largest cosmic structures. Hawking discusses two main scenarios. The universe keeps expanding forever, growing colder and emptier, a slow fade-out, or gravity eventually wins, triggering a big crunch where everything collapses back to a singularity. Data in 98 leaned toward endless expansion, but the mystery lingers, hanging like a question mark at our cosmic horizon. Quantum mechanics throws in radical uncertainty. Tiny fluctuations and weird particles popping in and out might influence the cosmos's fate unpredictably. Hawking likens this to a dice roll that governs not just games, but the entire universe's life story, where randomness rules in places we never expected. Finally, Hawking invites us to see science and philosophy blurring. Understanding the universe's beginning and end touches on meaning itself. We're left wondering, how much will we ever truly know? And is the mystery part of what makes the universe so wondrous? Remember that moment at the edge of the black hole? Hawking's journey took us deeper than we imagined, time flowing, space bending, mysteries unfolding endlessly. His cosmic storytelling transforms abstract science into a vivid adventure. Next time you look up at the stars or wonder about your place in time, try flipping a simple question on its head. What if the universe is stranger than you thought, and you're part of its grandest secret? Subscribe for more book summaries like this one.